Welcome and study with Tanzania Institute of Education.
When you work with solid shapes, it will most likely be with either surface area or volume. We're going to look at calculating the surface area of some common solid objects, starting with this cube. The surface area of a solid object is the area of the solid's outer surfaces. In a cube, for example, the surface area will include this area, and 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 the area at the base of the cube, all added together. To help us calculate surface area, we sometimes draw solids using a flat view like this, which shows us the net of the shape, as if we have taken the solid apart. The net shows us how many sides a solid has, and what each side looks like, which makes calculating surface area easier. With cubes, we know all the faces are squares, and therefore all their sides have exactly the same lengths. So to find its total surface area, all we have to do is find the area of a single side of the cube using the formula area equals the length of one side squared. Then, because we know a cube has 6 sides, we multiply this figure by 6. What happens if our cube is replaced with a rectangular box? A rectangular box is an example of a cuboid, a 3-dimensional box-shaped object with 6 flat faces and all angles at right angles. It will also have opposite sides which are identical to each other. Let's label this box and then work out its surface area. Here we have h for the height of the box, how tall it is, l for length, how long it is, and w for width, how wide it is. Once it's expanded into a flat surface, as we did with the cube, we can work out the areas of each side separately. The area of rectangles 1 and 3 are equal to the length times the height. The areas of rectangles 2 and 4 are equal to the length times the width. And the areas of rectangles 5 and 6 are equal to the height times the width. Now we can add all of these areas together to get the total surface area. Sounds easy, except if you had to repeat this same process to find the surface area of several cuboids, it would take a very long time. So we'll simplify this by finding a formula to help us. This is what we just worked out. Essentially, it says we have 2 rectangles with an area of length times height, 2 rectangles with an area of length times width, and 2 rectangles with an area of height times width. We can simplify this further by taking out the common factor 2, after which we're left with the surface area of any cuboid is equal to 2 times LH plus LW plus HW. But what happens when we work with curved solids like cylinders, cones, spheres, and hemispheres? As with cubes and cuboids, we can use formulae to find the surface areas for each of these solids. We'll start with a cylinder. A cylinder is made up of a curved surface and 2 circular bases. If we expand this solid into a flat surface, you'll see that the curved surface of a cylinder is made by a rectangle that is wrapped around the circular bases. To find the formula, we know the rectangle's length will be equal to the circumference of the circle, which is calculated using the formula 2 pi r. We also know how to find the area of a circle. We use pi r squared, and we know how to find the area of a rectangle, length times width. Here, the width will be equal to the height of the cylinder. A cylinder has 2 circular bases and a rectangular curved surface, so we can write this as 2 pi r squared plus h times 2 pi r. There's a common factor here of 2 pi r, and if we factorize this, we are left with a formula for calculating the surface area of any cylinder. Surface area equals 2 pi r, r plus h. Now the cone. A cone can be defined using three variables: its height, slant height, and the radius of its base. The height is the perpendicular height of the cone, and the slant height is the slanted length along a side of the cone. These three variables can be used to find the surface area of any cone. To do this, we need to know its curved surface area and the surface area of the base. The curved surface area is equal to pi times the radius times the slant height. The base is a simple circle, so we just used pi r squared. Add these together, and we have the formula we can use to find the surface area of any cone. A sphere only has a curved surface and cannot be expanded into a flat surface net as we have done with the other solids. However, there is a formula that we can use to work out the surface area of a sphere. This formula is surface area equals 4 pi r squared. R here stands for the radius of the sphere. As long as you know the length of the radius of a sphere, you can always find its surface area. What about a hemisphere? Well, a hemisphere is exactly half of a sphere. Think about how the Earth's equator is a line that divides the spherical globe into two equal hemispheres to the north and south. If you think about it, you'll realize you already know how to find the formula to calculate the surface area of a hemisphere. A hemisphere has a curved surface and a circular base. The curved surface will be equal to half of the surface area of a full sphere. We said that the formula to find the surface area of a full sphere is 4 pi r squared, so half of this would be 2 pi r squared. The surface area of the circular base is equal to pi r squared. Let's add the two parts together. When we simplify this, we are left with a formula for the surface area of any hemisphere. Surface area equals 3 pi r squared. That's it! You now know everything you need to find the surface areas of solid shapes.